You typed a web address, hit enter, and a page loaded in under a second. But that click just fired a tiny packet on a journey across the entire planet and back. Let's follow it. We'll trace one packet from your browser to a web server and home again. DNS lookup, addressing, routing hop by hop, the TCP handshake, and the trip back. This is the exact mental model the CCNA 200-301 expects you to own. First problem, you typed a name, but the network only understands numbers. Computers don't route to example.com, they route to an IP address. So before anything moves, your device has to look that name up. Your computer asks a DNS resolver, what's the IP for this name? DNS is the internet's phone book. The resolver replies with an address like 93.184.216.34. Analogy. You know a friend's name, but you need their phone number to actually call. Now your data gets wrapped in layers, like nesting boxes. Your web request is the cargo. Around it goes a TCP header with port numbers, then an IP header with source and destination addresses, then a frame for the local network. This is encapsulation. 2 addresses right along. The IP address says where on the planet the packet is going. It never changes end to end. The MAC address says which device is the next physical hop. It changes at every step. Country versus street. Is the destination on your own network? No, it's across the world. So your packet goes to the default gateway, your router, the single door out of your local network. Everything bound for the outside world passes through it first. Beyond the door, routers take over. Each router reads the destination IP, checks its routing table, and forwards the packet one hop closer, then hands it off. Run traceroute and you literally see every router your packet touches. But how does each hop know the next device's MAC address? ARP. A router shouts, "Who has this IP?" The owner answers with its MAC, and the frame is readdressed for that single hop. New frame at every step, same packet inside. The packet reaches the server. Before any web data flows, TCP sets up a reliable connection with a 3-way handshake. SYN, SYN, ACK, ACK. Think of a quick phone call. Can you hear me? Yes. Can you? Yes. Then you talk. Port numbers make sure the data reaches the right service. Web traffic uses port 80 for HTTP and 443 for HTTPS. The IP gets you to the building. The port number is the apartment inside it. The server is listening on 443. Now the server sends the web page back the same way, wrapped, routed hop by hop, addressed to your IP. The internet is a 2-way street, and the return trip follows the very same rules in reverse. Your device unwraps each layer, strips the frame, the IP header, the TCP header, until only the cargo remains, the web page. That's de-encapsulation. Milliseconds after your click, pixels appear on screen. The 200-301 won't just ask definitions. It gives a scenario, a page won't load, and expects you to find the break. DNS down, name fails, wrong gateway, can't leave the network, port blocked, service refused. Trace the journey, find the fault. If the packet journey finally clicked for you, hit subscribe. New CCNA breakdowns drop here every week. No textbook headache. And comment one thing. Which step, DNS, routing, or the handshake, still trips you up? I'll make it the next deep dive. Up next, the CCNA 200-301 study plan that actually works. A week-by-week roadmap, the labs that move the needle, and how to pass without drowning in textbooks. It's the plan I wish I'd had on day one. Hit subscribe and I'll see you in the next one.